Meeting is being recorded.
Those wishing to be noticed, put yourself on the attendee list. First, a item of business. The next meeting in 2 weeks is on New Year's Eve. Should I cancel it?
Yes.
I won't be there. That's
Okay, excellent. It's been decided. So we have 2 items that we have on the agenda from people, the analyze discussion, the authorization API troubleshooting discussion. I was thinking about talking about my multi-mesh operator, but I think that may be held off until tomorrow. I think I'm going to talk about it at the environments meeting. Chris, are you ready to talk about this issue?
Yeah, you want to go ahead and open that up?
Sure.
Have all the context here. This is just something I wanted to get some more eyes on. So one of the things that's been awkward about the current istioctl analyze is this discovery flag. So the reason we have this is that there are some resources that, and specifically if you're running in a files only mode, you just don't expect to be there. In a lot of cases, we won't expect users to be running with files, including not just their Istio config, but also all of their other Kubernetes level resources. And so we have this discovery flag to give some control. Right now, the behavior is that by default, the value of discovery matches the value of UseCube. So basically, we assume that if you're connected to a live cluster, that you do care about those resources, and if you're not connected to a live cluster, that you don't. So
I found that to be extremely confusing when I was writing validation for annotations, because I was explicitly passing in a pod with bad annotations, and it wasn't being checked because it had been told not to expect any pods.
Yeah, you're not the only one. It's definitely been a common point of confusion. So there's a couple of proposals kind of running around here. So the first and the most conservative is just to rename it so it's a little bit more obvious what it means. Nobody has objected to that, but some of these other options kind of make that redundant and unnecessary. Specifically, the other options we're looking at are basically, well, one of the things we can do is we can be smarter about the default behavior. So, for example, the example you gave where you included files that specifically are cube resources, maybe we should assume that if a cube resource shows up in the file set, that we should be paying attention to that particular resource type. And so then the default behavior would be, rather than this very coarse-grained, all Kubernetes resources or nothing, we look at what are actually in the files, and based on what resources are actually in the files, we decide which resources we're going to consider as being enabled and being part of analysis. Does anybody have any thoughts about that being the default behavior? What we should do if the user doesn't specify any extra flags whatsoever? Basically, this means that if you do connect to a live cluster with UseCube, we continue to assume you want all the resources. If you're doing files only, it'll be smarter and pick up on what's actually in your files and use that to decide what analyzers to run, basically.
If you're doing files only, there's a good case to be said for having the default be true and that it just always complain. So let's say I have a destination rule and there's no service or something like that.
Mm-hmm.
It could say, look, you got no service. And then you'd go, oh, well, of course I didn't include it.
Okay.
To me, the common case is you're sitting in front of a live Kubernetes cluster and you want it to do everything. The second most common case is you've got a pipeline and you're debugging a pipeline script and you know what you're doing. And you're expecting to see messages like, oh, I don't have that thing. To put a lot of smarts in there is going to make it tricky to use.
Yeah, it does open up
I lost some audio. Can anyone hear Chris or anything else?
No, we can't hear. I can hear you, Ed, but that's it.
Okay.
Can you guys hear us?
Yes, now we hear you, Chris.
Okay, yeah, we lost you. After whatever I last said, everything after that fell through. Or where did you last hear me, I guess?
You were explaining what about just restart.
Okay. Yes. So you make a very good point, right? That if we try to be clever about what we analyze based on the files that are provided, we are opening up opportunities for more surprising behavior that users don't expect. Whereas if we just kind of do the dumb but obvious thing of analyze everything, then there's fewer surprises there. I think the reason why we had this defaulted in the first place was just to avoid creating false positives in this files only case where somebody was analyzing files only. As you pointed out, it does seem like most interactive users are going to be wanting to use their cluster.
Yes, and furthermore, a message that can't find something is much better than the message, no message. But there's a third piece that we haven't mentioned, which is the Kubernetes resources I'm going to supply, like services and deployments, are very different from the resources Istio is going to supply. When I did the gateway rule, I had to, if UseCube was supplied, I would use the real ingress. But if there was no live Kubernetes, no live Istio, I just defaulted to a typical ingress. That's terrible. We should have a way to talk about that.
So there's a separate issue that tracks this idea, and what I was thinking we could do for that particular problem is rather than have kind of this special case behavior, we basically say for the files only case, we will, and for whatever you've specified as your mesh config, or just using the default mesh config if you haven't specified anything, then we will basically create a dummy ingress egress resource for you.
That makes sense, and that's kind of what I did, but maybe we should discuss those two things together, because a discovery flag and a include default Istio resources flag is very similar.
Well, I don't think we need a flag for include default resources, do you? I guess that's what I'm asking, is because that seems like a reasonable default behavior to have for the files only case.
It is reasonable, and I can't remember if I wrote on that issue for that item or not, but now that we have this Istio control plane resource that describes your Istio control plane, maybe you can supply that and it would puff it up into the things it's going to make.
So I'm not currently clear on what the functional differences and the overlaps are between the Istio control plane resource and the mesh config.
Yes. So the Istio control plane, I believe, is configures a Istio installer. And I can't remember. I know the mesh config includes stuff like TLS, and I know the Istio control plane includes stuff like, do I want a Kiali? Do I want an egress? Do I want an ingress?
Yeah, mesh config includes some of that too, like the ingress and egress. There's controls for that in mesh config.
So maybe we need some kind of logic that either based on one or the other, we have some defaults.
Yeah.
Or maybe this is too big in scope for 1.5.
Well, I think we may be getting a little into the weeds. I think to start with, we're okay looking at mesh config. We already depend on that for some things. It's already kind of a required thing. We already have defaults and everything set up for it. In a live cluster, it should be there, and it should. I assume we're still creating mesh config maps. Can anybody confirm that?
I think so, yeah. I think the difference is that the mesh config is not optional, right? Whereas the control plane config is optional.
Right. So does the mesh config get generated from the control plane config in an install then?
I believe that's how it works. I haven't looked at the code, but
Mesh config is a config map that's going to get mounted to just about all of the processes within the Istio control plane.
Right.
Whereas the control plane resource, as I understand it, is only consumed by the operator.
Okay, that seems like the right thing to do then is definitely to look at mesh config.
Yeah.
Okay, cool. So that matches what we have kind of sketched out for that other issue, which I am hoping to tackle.
I want to open up one irritation with that, which is it's my belief that this Istio control plane resource is what the user sees. They created their Istio with this control plane resource describing how they wanted it. And the operator, when it did the install, made the mesh config. So if you were in a pipeline, you might have a Istio control plane, but not yet have a mesh config. You'd have to sort of know what you were doing ahead of time and save a mesh config that had been generated from a previous install.
yeah, it kind of depends on whether or not you're using the operator though, right? Because not all users will be using the operator. So I think the answer is going to be both, but starting with mesh config, I think is the conclusion to this discussion.
For 1.5, we can just use mesh config, but we should think about what the user expects us to provide.
All right. So circling a little bit back to where we were before with the discovery flag stuff. So do we think we could just get rid of discovery entirely, get rid of per resource controls entirely and just assume everything's on?
I like assuming everything's on, but we have another command line flag to disable certain validations and things.
Yes.
Right.
Yes. This is yet another overlapping discussion we've been having where we want to have command line options to enable and disable. Basically, well, there's a few different cases, I guess. So one of the things we've talked about is basically specifying which analyzers you want to include or exclude. Another one we've talked about is based on the actual messages, being able to suppress messages that you want to ignore in a couple of different ways. And what we already have implicitly with the discovery flag is kind of a very big coarse knob for deciding a certain subset of resources you want to include or exclude. So
the reason I say it is because people writing pipelines are going to have a policy that you can't check anything in unless it passes clean. So whatever option we have, there should be some option to let you say, I know that what I'm supplying here is not complete.
Yes. Yeah, I think of the three things I just talked about, the suppression is probably the most useful and immediately important. So Joe Selman is working on that. He's picked up that task and he was going to work on adding the suppression. I don't know if he's in this meeting today or not. You are? Okay, cool.
I'm tackling that today. I hope to have it out hopefully soon in a PR.
Nice. So my current thinking is also that I'm not sure per analyzer controls are going to be very valuable. And I think if we do have kind of more front-end controls instead of output suppression controls, they should be based on resource. So maybe at some point we can still add, include these resources or exclude these resources for fine-grained control of edge cases.
Yeah, Chris, I think being explicit about that is a good idea rather than trying to build in super intelligent defaults, because there's just a number of different ways that people use Istio. So for instance, if you're not using the sidecar injector, then your pods or your whatever level of abstraction, your replica sets, your deployments, whatever you've got in your CI/CD pipeline should explicitly include the what am I trying to say? The sidecar. Whereas if you're using the sidecar injector, then that's something that you wouldn't necessarily want to check at the CI/CD level. So exposing a very complex knob is probably a good idea in this case, as long as for the simplest case where you're actually just running it against a cluster, you don't need to fiddle the knob, if that makes sense.
I think that does make sense. So the way Joe and I were talking about this before, so a few weeks or a month, I don't remember exactly how far back, Joe was presenting his plans for kind of adding these controls for suppression and for analyzer selection. The big thing that Joe and I have been talking about is basically what we had been planning to do in terms of selecting analyzers where you can explicitly include or exclude them. We would do that for resources instead. The reasoning being that analyzers are kind of a little bit too internal. We don't want users to have to know what a particular analyzer takes as inputs, what kind of messages it can output. Users are probably going to want to reason about specific messages and specific resources that they know are definitely should be there or shouldn't be there, they care about or don't care about.
That sounds like a good idea to me.
So another idea that I think it's further down toward in the conversation on this issue, I think it was you, Ed, that brought this up, the idea of maybe inverting the UseCube flag. Let's see. Oh yeah, there it is. So going back to Ed's point that the most common case is going to be interactive, and files only is really going to be kind of the more advanced case. Should we flip this so that instead of UseCube being false by default, it's true by default? So users generally just don't even have to specify it.
Yes.
I feel good about that too. Anybody disagree?
Can we somehow, if I don't have a Kubernetes cluster set up?
By the way, can you guys hear Clay?
Yeah.
Yeah, I can hear him.
Okay.
If I don't have anything set up, can you not error? Like, what I'm concerned about is that I'm imagining some kind of support use case where I'm looking at Stack Overflow.
Mm-hmm.
Somebody has copy pasted a file, and I just want to check it real quick. I don't want to have to pass in like 3 different flags to say I know I'm not running Cube. I know don't ignore all of these resources. I know all of this stuff. I just want you to analyze this file. And like, it's also for onboarding. Like, if we ask people playing around with the tool, hey, pass in these 3 flags that I'll explain what they mean later, like that just adds friction. I am all for being explicit, but I'm also a little bit concerned that we're adding a lot of friction into this one case.
What if we set it to be true by default and then just look for a kube config, right, and check that it doesn't exist?
Right, and then as long as it runs, if it doesn't, like if I can't find any kube config or anything and it still runs, like that's fine.
So the behavior would then be basically, if there is no kube config, we output a message saying, hey, we couldn't find a live cluster, so we're going to just look at your files and then just run that way. So rather than failing entirely if it can't find it, okay, that seems reasonable to me.
The difficulty, though, there is that there are some resources that you may expect to exist even in the files. In a CI/CD system, for instance, expecting the services to be expressed explicitly is very reasonable and sane, right?
Mm-hmm.
So that there are going to be, in the file case, there are some Kubernetes resources which we would expect and some which we wouldn't. And then there are some that are kind of in a gray area where sometimes you'll expect them and sometimes you won't. I don't think we can automatically interpret what the user's intentions are there.
I think that, and correct me if I'm wrong, the way I understand what Clay's saying is basically, if we're going to make UseCube true by default, we should degrade a little bit more gracefully than we would today. And instead of just throwing an error, we actually do what analysis we can, and obviously just include whatever messaging that makes that clear.
As devil's advocate, most people, or every other Istio, or most other istioctl and all kubectl commands are going to fail exactly the same way with a timeout talking to 8080 if there's no Kubernetes config. Whether or not you set UseCube inspecting somebody's file, UseCube just adds a few seconds to pull some resources down. It seems like difficult to tell if a user has a kube config. Maybe they're picking up the default kube config in the user's home directory.
That's true.
I would just, I would not worry too much about the case where the user doesn't have Kubernetes and wants to validate an Istio file.
Okay, so what you're saying is basically that the rest of istioctl already kind of has this problem where we assume that there's a cluster there, and if it doesn't, then we currently just let it fail, and so that it makes sense to just kind of be consistent with that model.
I think so.
Okay.
Do you think you have enough to?
I don't have a
finish
rebuttal.
this up?
Sorry.
Right. I don't know. Yeah, I guess I was waiting to see if Clay had anything else to say about that, but yeah, I guess not. All right. So I think we've covered all the things that I had bulleted down here. Anybody have any other questions or thoughts on this?
My one quick thing would be maybe use the language require and ignore instead of include and exclude.
Okay.
I think that makes it a little bit more obvious, because I think what we're really doing is saying error if this doesn't exist, or ignore if this doesn't exist.
All right. I'm on board with that.
Shall we move on to Troubleshooting API?
Yeah, sounds good.
Okay, Romain, shall I open this document?
Yeah, please. And scroll just a little bit down. Just this paragraph is the new stuff I want to talk about. Yeah. So 2 weeks ago, we discussed the overall API in the details. And one of the big feedback was how do we authenticate and authorize access to the API, which was an open point at the time. And we left with the idea of just binding the API to loop back in pilot and require to kubectl exec into pilot for that. One concern that was raised after that is that it means that anybody who has access to pilot has access to all the pods in the cluster, which is a bit too much. So we wanted to see what we can do to keep the namespace level authorization that we currently have with kubectl exec. And this is what we came up with. So we are proposing to use a Kubernetes API server aggregation layer, which is, according to John, who checked that, this is enabled everywhere. I checked this enabled on GKE, and it allows to register a path prefix with API server, and API server will forward HTTP request to a backend. And API server will do authentication and forward in headers the username of the authenticated user to the backend. It does mutual TLS authentication with the backend. And it does also access control. So we can also have policies to control access to the endpoint. So that relieves a lot of responsibilities from the backend. And in addition, on top of that, we can also, once we have, because we have the username, we can also do RPC calls to API server to check whether the user has read or write access to the namespace on the pod resources. So the idea is that each troubleshooting operation will either be a read or a write operation, which will translate roughly in authorization in terms of get or patch on pods. And we can verify those permissions using the normal Kubernetes authorization and policies. And those policies in Kubernetes are at namespace level. So we can verify access per namespace. So I think that addresses all the concerns we had. So we can control access to the troubleshooting API, and we can control access read or write on a namespace level. Another added bonus is that because it goes through the API server, if a user has kubectl access to the cluster, then it will also have access to this API. No need to use ingress to have access to the API from the outside.
Everything here looks good, although I've never looked at the aggregation layer. Do we know if it's in all of the clouds where Istio is being used?
So maybe John can jump in. John said
Yeah.
it's part of the.
Can you guys hear me? Yeah, so we were actually looking at this for a completely different thing. The aggregation layer is a part of the conformance test So presumably pretty much everyone has support for it. It's actually used internally in Kubernetes and a lot of Kubernetes distributions. So I think it's pretty well standard. We double check that kind K3s, IKS, and GK support it at the very least. But based on it being in conformance, it seems very likely everyone's using it.
Okay.
Thanks, Jen.
I don't have the skill to understand if this is a good security design, but people who know what they're doing have looked at it and think it's secure.
It looks it's pretty common. There are some, and it's they make it relatively easy also to extend. So there is a whole framework to actually implement those backend API servers. Looks like it's something that's pretty well supported and well tooled. And anyway, it's better than anything we could do ourselves. I don't want to implement an authorization system on our own. So it's or pull in Vault or something else into the picture. So that's good. At least it's self-contained. We don't need to introduce another system in there.
Like that.
I have a quick question. So I see that it's controlled based on the pods resource. Is there any way there could be a more explicit resource for this API, something like Istio debug or something like that? Or can you not introduce a new resource in this case?
So this is purely like, when you look at permissions, when you create a role, you add permissions. You need to say in the permission what resource it applies to, right? So you say, okay, I allow this role to do get on pods, right? So if we need to use an existing resource, otherwise we need to introduce a new CRD.
What about a sub-resource? Doesn't pods have some sub-resources?
I don't think so.
I think you could add a sub-resource if you wanted to, like under pods. You can see some Kubernetes resources have them. Whether that's a good idea or not, I can't answer.
I think port forward is a sub-resource on pod.
What will give us, right? Because we want to. The sidecar is pretty much tied to the pod. We could introduce a sub-resource, but I thought it would be the right level of granularity here. It doesn't matter. Anyway, we can pick any kind of resource. Honestly, I'm really open to that.
Yeah, I guess to be clear, I don't think that pods is necessarily wrong. I was just thinking there might be a use case where somebody wants pod access but not access to the debugging API, for example, or vice versa.
Correct. That said, here we have
the existing port forward sub-resource on pod is very close to what we've been using before for this, so you could possibly use that.
I'll look into that.
If you think about it, if you have access to the pod, particularly if you have access to modify the pod or to port forward to the pod, then you can connect to Envoy's debugging API. So creating a separate resource to represent the Istio debugging API for that might give a false sense of security.
That makes sense.
Because this is a perimeter thing, right? Once, theoretically, from any pod that's got connectivity to Pilot, I can get this information anyway without going. I mean, obviously, you need to get to the pod in the first place, but without going through this LC layer.
One interesting thing, though, is it is locked down to the namespace. But if I have access to this API, can I get information across namespaces?
Yes, API support giving a set of namespaces, right? But the API, the server here as a STOD will check for each namespace. So if you request mesh-wide, you do a mesh-wide query, we will check that you have the right to do that. If you give, say, namespace QA and prod, we will check that you have access to both QA and prod. If one is not allowed, we will reject the whole RPC.
Okay, cool. Thanks for clarifying that.
So yeah, I will write into the detailed design doc all those details, clarify which operation is read, which one is right, to get feedback on the overall idea of using aggregation layer. I get my main feedback here is look into maybe using a sub-resource.
Thank you, Romain. This looks really great. I appreciate you looking into the security stuff. That, I believe, is all we had for on the agenda. Do we have any other things to discuss today?
And I had a question for Roman. Looking at the Kubernetes documentation for API aggregation layers, there's a lot of before you begin and setup that seems to be required. Is this going to complicate the install use cases for our end users, or is that taken care of automatically?
So that's the point that John made, is that this part is already done on the platform because it's part of conformance. So this is already enabled. So the hard part of setting up all the flags on API server, this is taken care of already.
I see. Okay, thank you.
Yeah, that's a scary part, but this is already taken care of.
So you say when you say it's already taken care of, you're talking presumably about GKE. If you were to install your own Kubernetes server, then you would need to go through these steps?
You do it by hand, and you want to be conformant, you have to take care of that, yes.
Okay.
Minikube. Minikube.
When you check that. If you check that kind also supports it, I've not checked yet.
Okay.
When I heard you talk about kind as supporting this, are you saying that by default it's already enabled, or that you can toggle kind with a number of config files and settings and magic that will eventually enable it?
Let me check right now. My kind is broken right now, but I'll get back to you on that. I would expect it's enabled. My cluster is broken right now. I'll get back to you on that.
Yeah, that's fine. Thank you.
Thank you.
Okay, thank you, everyone. I guess I will see everyone in a month. Please add to next month's agenda if you have anything to discuss, and use the Slack channel, and I will see everyone next year. Thank you.
Here, everybody.
Exactly.